Hello everyone, this is Sneha, and my one advice to you before I begin this session is believe in yourself as I believe in you. And I believe you have an amazing talent inside you. And to help you on your journey today, we are going to look at Georeference scanned topographic map using QGIS. At the end of the session, you will have a fair understanding of what is georeference, what are the steps we will use in georeference, what is map projection, and what are the steps we use in map projection. Most GIS projects require georeferencing some raster data. Georeferencing is the process of assigning real-world coordinates to each pixel of the raster. Many times, these coordinates are obtained by doing field surveys, collecting coordinates with a GPS device for few easily identifiable features in the image or map. In some cases, where you are looking to digitize scanned maps, you can obtain the coordinates from the markings on the map image itself. So using these sample coordinates or GCPs, the image is wrapped and made to fit within the chosen coordinate system. So in this video, I will discuss the concept, strategies and tools within QGIS to achieve a high accuracy georeferencing. So this video is to georeference an image which has coordinate information available on the map image itself. Overview of the task. We will use a scanned map of Kalyan. Kalyan is a city in Thane district of Maharashtra state, in Konkan division and a part of Mumbai metropolitan region. So let us understand how to download scanned topographic map, which is a prerequisite in order to start georeference the scanned topographic map. So here we have Universities of Texas Library website, which has an excellent collection out of copyright scanned topographic map that one can use for research. So for convenience, here you can get this link to download directly the scanned topographic map. Then download the Kalyan city map using this link and save it as a JPEG image on your hard drive. Also, you can observe in this website, they have already mentioned the zone that is 43. Okay, so if you have any doubt here, you can also check out in the Google Earth. So here it is showing Kalyan in the state of Maharashtra with 43 zone. So this is how the downloaded scanned topographic map of Kalyan city looks. So now that you have data ready, so you are now all set up for georeferencing. Open your QGIS software. So here georeferencing in QGIS is done via Georeferencer GDAL plugin. It is a core plugin which is already installed in the QGIS software. So go to plugin in the menu bar and click on manage and install plugin. Okay, then you have here the plugin window which is showing the Georeferencer GDAL plugin in the installed tab. Okay, so enable it. To check whether the Georeferencer GDAL plugin is installed, just go to the raster in the menu bar and check here the Georeferencer. So click on it. The Georeferencer window is open now. So in this Georeferencer window is divided into two sections. The top section where the image will be displayed and the bottom section where a table showing your GCP point will be appearing here. So now we have the features which is used in Georeferencer plugin tool. So first we have open raster, then we have generate GDAL script, save GCP point, add point, then move GCP point, zoom in, zoom to layer, zoom next, and then link QGIS to Georeferencer, local histogram stretch, start georeferencing, load your GCP points, transformation setting window, and delete your GCP points, pan, then zoom out, zoom last, link georeferencer to QGIS, and here full histogram stretch. So let us use these features to know that how it works in the Georeferencer plugin tool. So in this window, Georeferencer plugin window, so go to file menu, then you can get here open raster, or else you can directly get this open raster in your menu bar. You can use that, or else you can use by going to file and click on this open raster. So after opening that, the next window will appear, that is data source manager. So here data sets, go to this data sets, click on this browse button. So it will directly open the folder where you have already saved your JPEG map image. So click on this and click on open. So it can seen here in the raster data sets. Then click on add and close this window. So you can see here it is loaded in the top section of the Georeferencer GDAL plugin. Okay, now check and zoom it and check where the coordinates are seen in the map. So in this map, you can see the coordinates in the corner, 4 corner. So add all these coordinates in the GCP table. So the first coordinate which shows 72 degree in the X coordinate and 20 degree in the Y coordinate. So you can also see here enter map coordinate. It will helps us to enter the coordinate and it will directly appear in your GCP table. So now I have entered here 72. It should be entered in a decimal form. You can also calculate that conversion from degree to decimal. So 72 plus, if you have any minutes, that minutes divided by 60 plus your second value, seconds. So that divided by 60 into 60. You can also, by that calculation, you can also get the decimal. Or else I'll show you in the entering the third point how to enter that. So here after entering, click on OK. So you can see here the first GCP point has been entered. And you can see it is, the ID is 0 here. Okay, then same, it will appear the point where you have already clicked. You have to left click the mouse button, it will appear. Then same way I have made a second point also. So this is a where third point, just to show you that how to enter if you have minute value. So 73 degree 30 minutes I have. So what I have told you already, the calculation, you can use that calculation and you can enter the value in terms of decimal. If not, you can enter like 73 space 30 and here 19. Then click on OK, it will appear in the GCP table. The same way, just add all the 4 points. It looks like this. Okay, so source X, source Y and XY, or what you have already entered, and the ID 0, 1, 2, 3. Okay, so then after adding all these GCPs, the next step is to transformation settings. So you can check here settings and you can see here transformation settings. So before starting with this procedure, let us know about this transformation setting. So after you have added your GCPs to the raster image, and you need to define what the transformation setting for the georeferencing process. So depending on how many ground control points you may want to use different transformation algorithms. Choice of transformation algorithm is also depend on the type and quality of input data and the amount of geometric distortion that you are willing to introduce to the final result. So currently the following transformation types are available: linear, Helmut, polynomial 1, 2, 3, and thin plate spline and projective. So before using this, let us understand what it means. So linear algorithm. So you can also see this in here, transformation setting window. Okay, so here we have linear first. So linear algorithm is used to create a word file and is different from the other algorithms. As it does not actually transform the raster, this algorithm likely won't be sufficient if you are dealing with scanned material. So in the same way, the Helmut. So Helmut transformation performs simple scaling and rotation transformation. And then coming to this polynomial 1, 2 and 3. Okay, so here this 1, 2 and 3 algorithm are among the most widely used algorithms introduced to match source and destination of the ground control point. And the most widely used algorithm, this polynomial algorithm, is the second order polynomial transformation, which allows some curvature. Okay, it shows some curvature. And the first order polynomial transformation, which preserves collinearity and allows scaling, translation and rotations only. So you can use with the polynomial 1. So in this procedure, I am using polynomial 1. So let us also discuss about thin plate spline. So this algorithm is a more modern georeferencing method, which is able to introduce local deformation in the data. So in this algorithm, useful is when very low quality originals are being georeferenced. And the last is we have projective. So projective transformation is a linear rotation and translation of coordinates. So then this is how about the transformation settings. So we can know that which can be used for our data. So it is depend on the data what you are using for your research work. So here I am using polynomial 1. So next we will discuss about the second method, that is resampling method. So in the resampling method we have again different methods, that is nearest neighbor, linear, cubic spline and Langzos. So this resampling method, it is a type of resampling that you choose will likely depending on your input data. And ultimately the objective of the exercise, if you don't want to change the statistics of the image, you might want to choose nearest neighbor. If you don't, not at all, if you are interested to change the statistics, you can use the nearest neighbor. Whereas a cubic resampling will likely provide a more smoothened result. And it is also possible to choose between 5 different resampling methods. All these 5 different. But it is depend on your particular data for your research. So now the third we have here, target SRS. So before choosing here, let us have some discussion about this target SRS. So coordinate system in GIS. So we have two types of coordinates. So the one is geographic coordinate system and the second one is projected coordinate system. The short form of geographic coordinate system is GCS and the short form of projected coordinate system is PCS. And this GCS indicates the location on three-dimensional Earth surface. Hence, its units are represented in degree, minutes and seconds. And coming to this PCS are produced by projecting this GCS into a flat 2D surface. So PCS indicates the location on plane surface. Hence, GCS is necessary to define PCS for a data in GIS. And the unit of this PCS is in meter. And there are hundreds of geographic coordinate system and thousands of projected coordinate systems are existing for use. In addition, we can also develop our custom coordinate systems. And then we have WGS. WGS indicates World Geodetic System 1984. The coordinate origin of WGS 84 is meant to be located at the Earth center of mass. It is used in cartographic, geodesy and satellite navigation including GPS. It is established and maintained by the National Geospatial Intelligence Agency, USA. And then next we have EPSG, European Petroleum Survey Group. It stands for European Petroleum Survey Group. It is an organization that maintains a geodetic parameter database with standard code. So we called as a EPSG code. Okay, I think you have this clear understanding now. EPSG 4326 WGS 84. Also, we have a small explanation of this component of geographic coordinate system. In this, we have angular units. Angular units helps to measure on the spherical reference system. And then spheroid. Spheroid is a reference spheroid for the coordinate transformation. Then datum. It defines the relationship of the reference spheroid to the Earth surface. And then prime meridian, the longitude origin of the spherical reference system. Okay, and then so after loading this and give the output raster in the georeferencer or any of the folder what you are using as a .tip file format, and you can click on this save GCP points. Okay, and then we have here load in QGIS when done. After completion all the georeferencing, it directly load in your QGIS interface. So you can click, or you can, if you are not interested that, if you want to just newly if you want to open the georeferenced image, don't want to enable this. Okay, and then click OK. So then after completing the transformation setting, the next is you have to georeference your image. So click on this start georeferencing icon. So it will start georeferencing. So after your transformation setting, you can see the error over here. Okay, this is error. So if you have the maximum amount of coordinates, this error can be reduced. If you have the less amount of coordinate, then the error will be maximum. So this we will be getting after the transformation setting. Okay, then start your georeferencing. So it will show the image like this in your QGIS interface with naming modified image. Okay, then we have the next procedure. It is a map projection. Is nothing but where we are using a projected coordinate system. The conversion of the 3D surface to the plain flat surface. So here in this map projection, the procedure starts after the completion of your georeferencing the raster image. So just open your raster image, what you have georeferenced now in your QGIS interface. And then after, click on this layer and go to properties. So there in the properties, you can check here the information. See here, EPSG 4326 WGS 84 Geographic Coordinate System. So now you can understand that this map is in GCS format. That means it is in a 3D view. Okay, so then what you have to do is click on this layer and go to export, save as. So if you go to save as, it will open a folder, that the window. So from there you can give the file, browse here and click on this. You can save this as a projected or whatever your name. Okay, so after projecting, this file will be saved in this particular folder where you have this modified georeferenced raster image. There you can also save your projected image. Then click on save. Then the same, this CRS, what we had in the before. This is a GCS. Now you have to convert that into PCS. So for PCS, we know the zone, that is 43 north. So search here 43 north. If you search the 43 north, it will open like this. UTM zone 43 north. So UTM stands for Universal Transverse Mercator, the projected coordinate system. So UTM is a international locational reference system that depicts the Earth's three-dimensional surface in a relatively accurate two-dimensional manner, and it is used to project the spatial data located between 84° north direction latitude and 80° south latitude. So this is our authority ID, that is 32643 for your 43 zone. So then change this and directly you can click on OK. So here you can see the new projected georeferenced map. Clear? So you can again check the information whether if you have any confusion that this is projected or not. See here, if it is projected, then the information is shown here, UTM zone 43 north projected. So this is how the procedure of map projection. So this is the recap of today's session. So we have discussed about how to download the scan topographic map, and then we have discussed about Georeference GDAL plugin installation and steps involved in georeferencing scan topographic map, then steps involved in map projection, and types of coordinate system we used. We discussed a whole thing in detail, and transformation setting, the types of transformation settings, and the resampling method and the types of the resampling method. Thank you. Please subscribe to my channel, like and share. And if you have any feedback about this today's session, please comment. And if you have any doubt, you can also contact me through the WhatsApp number. Thank you.